Good morning. How was the party? As the room is supposed to be fully booked, I would assume the party wasn't that bad. Right, so welcome to the session about connected cars and about why VMware would be in that space. As a little disclaimer, as usual, you have to read it all, understand it, and on your way out there will be a test. And if you're not passing it, you have to stay in Barcelona. So what we are showing you today are not finished products, so it's nothing you would be able to buy. They are technology ideas and technology samples, basically. And what we are looking at is to actually partner with automotive companies and automotive suppliers to make this a real thing. So, the agenda for today, we want to look into a little bit what's happening in the automotive industry. So why are we here? Then about how we can use some of the technologies you all might be already using in your data center, but now use them in the cars. And show you some really crazy stuff, which you might think is totally out of this world, but I assure you it's not. But it's really cool. So if you look at the car industry, and I got this slide off Mr. Straub, who is the CIO of BMW, and he showed this publicly, so it's nothing which secret I would show you. And basically what the car manufacturers, and they call themselves OEMs, what they say is, well, the people are not driving enough in our cars, right? And so actually this is a rather optimistic view of things. So the average driver is using the car about an hour a day, right? And the rest of the time you do something else. You are either at work or you're at home. And so what the car manufacturers want to do, they want to get into the home and the work. And they can do this only by providing services which might be somehow related to the car, but they might not necessarily be consumed inside the car, right? So that's what this chart says. And to create those services, you obviously need data out of the car, you need to send data to a car, and so Gartner says that by 2020, there will be about 250 million connected vehicles on the road. Now that poses a completely different challenge to car manufacturers because as usual in the car industry, they will start rolling that out in like the premium models, so BMW 7 or Mercedes S-Class. And that still means that probably by 2020, there will be 30 to 50 million cars reporting into each and single car manufacturer. And you don't want to do this in your own data center, right? Because we're talking about exabytes of data generated there. An average car today generates 25 megs of data every second, right? So you can imagine how much data is actually hitting those data centers. Right, so if you look at a car today, it's made out of what they call electronic control units or microcontrollers, and there's about up to 100 of them in a car. And they're not really computers. They're more like small pre-programmed chips which have a certain functionality, like controlling the windows or the air conditioning or the injection system and all those things. And then of course you have all the sensors and actuators, all the buttons and the electric motors and stuff like that. And in between you have complex bus systems. There's different bus systems. The one everyone knows is the OBD2 bus. That's the only thing you see in the car. It's a little port which is underneath your steering wheel where you can actually plug in stuff if you want to. And it's about 2 kilometers of copper wires. And so it's about a third in the car, it's about a third of it is made up out of these control units. Another third is made up of those switches and actuators. And the last third is code. So on all these control units is about 100 million lines of code running in the car. So this is really a data center on wheels. The problem with these 100 million lines of code is, and I come from a banking background, so I developed and created a new core banking system back in 2003. We rewrote everything completely in Java, and we had 40 million lines of code, but this thing could do more than a car does, right? I mean, you could buy mortgages and transfer money and run ATMs of it and things like that. So you always wonder, why is there 100 million lines of code in there? The reason is that usually they're only adding code, they're never removing code, because they cannot be sure that when they remove something, they break something else. It's like firewall rules, right? I mean, you're always adding, you're rarely removing stuff. So that's the reason. Now, where the car manufacturers want to get to is 80% code. Why is that? Because software eats the world, right? Everything is software today, and if you look at a car which is, I mean, like a middle or upper class car, there's a ton of software in there for the navigation system and all that. And the more of that software you have in the car, the more likely it will be that people like to use it, and the more likely it is that you can actually update that stuff without bringing the car into the garage every time. So that's the reason why they want to have much more code. Right? And of course, everyone is looking at Tesla, which has this huge screen in the middle, and everything is done on software. And the car manufacturers are a bit envious on that, but that's a different concept, but they want to get there. So what's all that connected car stuff about? So basically, there's a value chain to it, right? Things are only done because there's a value to it. And in the connected car world, it starts on the left side with the machine itself, or the car, which has ECUs and all that cool stuff. And then you need a gateway to actually get data out of that ecosystem in the car, then transfer it wirelessly via mobile. And then you need to take that data, store it somewhere, and as I said, we were talking about exabytes of data there. Then you need to analyze the data. And then, after you did that, you want to do something with the data, because it's no good to have the data and store it on a disk, right? So what the car manufacturers want to do is to actually expose that data again to themselves, to, for example, improve the cars, but they also want to expose it to other users, like insurances, like dealerships, like yourself. And so there's a whole ecosystem which has to be provided with that data. And as it so happens, when we looked at this, we found out that, oh, look at that. We have AirWatch, which we can use to manage mobile phones. So maybe we could manage a car with AirWatch as well. And we realize operations which we use to manage servers in the data center. Well, maybe we can use it to actually analyze data which comes from a car. And then there's Pivotal, our sister company, which is doing like big data analytics. And they're also having a product which is called Cloud Foundry, which you can use to create web apps and applications and apps to actually then expose that data. And of course, that all should be running on a software-defined data center and or on vCloud Air. Right. So let's talk a little bit about this, and for that I'd like to call on stage Emil Novakov, who is our lead systems engineer for AirWatch, and Greg Bolella, who is a member of our CTO office.
Good morning, everyone.
Morning.
So, what are we making out of this? Why is AirWatch a good thing to actually manage a car?
Yeah, so as you mentioned, AirWatch, obviously, I'm sure you've heard about AirWatch or you've used it. You know that it's a tool or a platform basically to manage smartphones and tablets. So the approach we had is, at the end of the day, a car is also a mobile device, right? It's a smartphone on wheels if you look at things a bit differently and a bit out of the box. So the same concepts that we apply to a smartphone around provisioning of software, remote software upgrades, configuration, data acquisition, etc., that we do on iOS, Android, Windows Phone devices. Why not apply these same concepts, the same technology, the same tools that we've developed for smartphones, but for the car? So we had recently a project together with a large American beverage company that we all know from the black drink that we all love. So what they do is they use AirWatch to manage their dispensers. So when you go inside McDonald's or Burger King, you have this, called a freestyle beverage dispensers with about 100 different drinks available. You can click on them, etc., etc. So these beverage dispensers are managed by AirWatch, so we can provision remotely the list of drinks. We can check how many ingredients are left, and we can go and refill the machine before the drink runs out. So these beverage dispensers are running an operating system called QNX, which is a real-time operating system, a Unix-based operating system. And guess what? The operating system that runs in our cars in the head unit, so the head unit is basically your HMI, your human machine interface in your car, it also runs QNX. So basically we can, thanks to this management of these beverage machines, we can at the end of the day also manage a car. So this is the vision we had around AirWatch managing cars.
All right, very good. Greg, VROps.
Okay. So in a similar vein, I've been looking at our data center management suite. And over the last 18 months or so, I've been our CTO asked me to look and see how VMware's set of products and the things we do intersect with the Internet of Things. And one of the themes to come out of that investigation is that there's emerging a three-tier architecture in the Internet of Things, something that we didn't envision back in the late 90s and early 2000s. And that's kind of a local gateway tier. So it's not going to be every sensor directly connected to the cloud with its own IP stack. There'll be local connections to systems that manage the set of things with proprietary protocols and do some aggregation. So in the car, that might be the head unit. That could be considered, part of that is an IoT gateway. We're going to have IoT gateways in buildings, in homes, in municipalities, and they will be communicating with the set of things, aggregating the telemetry and moving that telemetry, some of it, to the cloud.
But wasn't IP6 supposed to solve all that?
Right, but the gateways are not coming into play because of that particular reason. They're really for, there's a mismatch in expected lifetimes, so we can evolve software on the web side and then let the software stay and not necessarily evolve it on the thing side. Oh. Many of those things are fixed function, so they need to remain as they are. So the idea then is we have this tier of essentially general purpose systems in the IoT infrastructure. And the question is, how are we going to manage that tier of systems? And we think that an interesting abstraction is extending our data center tools and their capabilities out to that external tier of systems, because they're just systems. They're just like a system in the data center, only they're not in the data center. And so the first tool we're doing this was VROps, and we'll show you some things we're doing with VROps in managing that gateway tier, or monitoring the health of the gateway tier and the things associated with it.
All right. So I said once we have that data, right, we have a ton of different things we can do with it. And so if you look at this picture, which shows some of the stakeholders or the ecosystem which might be interested in that data out of the car, which obviously is the car manufacturers themselves, but it's also the dealerships, because if they would know that you have a a component in the car which is bound to fail in the next 4 weeks because we do data analytics and we do correlations, they could give you a call and say, hey, come on, bring your car to the dealership, we have to fix something, rather than you finding out about it and then have to tell the dealership, right? So that's the idea, to have preventive maintenance kind of things. Then it's all about the smart cities, which are will be connected to those cars for parking space and other things, right? Finding a free charging spot for your electric car and all those things. So there will be a lot of interconnectivity going on. And that's obviously fleet management. And by the way, the truck manufacturers, they are further ahead than the automotive industry on this. I mean, they are running already autonomous trucks like Daimler did last week. On a normal German Autobahn, they just put the truck there and let it drive from Stuttgart to Munich. Okay, that's one Autobahn. It's fairly easy to do, but still they did it. And then there's insurances, because they want to offer more flexible tariffs. So if, for example, you live in, let's say, Germany, you pay a certain amount for your insurance. If you will be driving to, let's say, Ukraine, that will suddenly go up, right? Because they know you cross the border, you're in a different country, which might be more dangerous than Germany, so the car insurance goes up. When you go back to Germany, it will go down again, and things like that, right? To do that, you need all that data from the car. So that's why this is a very important topic. Right, and it takes us to the demo for vRealize operations.
Okay.
So it's a black screen for the moment.
Is this a Mac problem? Wouldn't it happen on a Dell? No, we have like 90% Mac, so.
What happened now?
Yeah, maybe try just to...
Yeah.
Can you do the usual engineer thing, which would be worked before, or it always used to work? Ran out of battery?
No. The screen just decided, no, it's not yeah, it went to sleep, but forever.
Yeah, while they're fiddling around with it. So the insurances, what they do today, they provide you with a little dongle, which you can put on this OBD2 plug in your car, and that connects then to your mobile phone. The mobile phone sends the data to the insurance, and they would know that you're driving crazy or you're driving normal, right, and things like that. Now the problem with that dongle piece is, if you change the insurance, you need a different dongle. If you want to do something else with the data, you would have to like stack a ton of dongles on in your car. So that's all very complicated, and you always need your telephone to do it. So if you don't have your telephone with you, it doesn't work. And so that's why it's much more interesting for the industry to actually use the built-in systems in the car and send the data out, and not having it connected to the telephone. So even though they're telling you that it's like Google CarPlay and Android Auto is the way to go, the car manufacturers always want to make sure if you lose your phone or you're forgetting it at home, you will still be able to operate your car and access all the functions it has, right? So that's why it's very important not to totally rely on a telephone to be there. Oh, it seems we are up and running.
Track, yeah.
Almost.
Almost 1 minute.
It was working before. That's it.
Yeah. Switch back to the presentation. Yeah, it's fine.
Ah, there we are.
Mm-hmm. So here we go. We're back on track. Good. Sorry for that. The mic just decided to sleep, and now it's back on. So, Greg.
Okay. Thanks, Emil. Okay. So this is vRealize Ops Manager. How many recognize that? How many have played with VROps? Well, okay, a few of you. So its purpose, for those who don't know it, is really to gather telemetry from resources in a data center, analyze that telemetry, and give the user the opportunity to create alerts using symptoms and the values from the metrics and then functions of those super metrics to indicate when some piece of equipment, some VM, something in the data center is no longer healthy and it needs attention. So we've taken that and extended that notion out of the data center to IoT gateways. And we've written a special adapter. For those of you who don't know, you can write adapters as plugins for VROps. And those adapters, they're the ones who gather data. So our adapter connects over a WebSocket to an Intel IoT gateway. And you can see the resource I have representing that gateway is this little icon here. This represents our adapter. And this is actually the screen from the smart building demo we have running in the Intel booth. It's not running now. The Solutions Exchange isn't open. But this is the data that was there yesterday during the show. So you can see we have things like the main doors, the glass panels, a fan, solar panels, elevator, temperature sensor, and lights. And the demo we show is this temperature sensor here, and we're using it to indicate fire. So you can actually just grab the temperature sensor with your hand. What happens then is you'll see one of these little peaks occur in the output of that metric. That will create a REST notification from an alert. So we have a symptom created that monitors the temperature. It's set at a certain threshold value. That's part of an alert. When the temperature goes above that threshold value, the alert's triggered. It sends a REST notification back to the gateway, and the gateway puts the building in fire mode. It opens the doors, elevators go down to floor 0, and the stuff that buildings normally do. When the temperature goes back down, the alert's canceled, and the building goes back to normal. And so we can monitor all the things in the building and the telemetry from them. So I'll show you now a bit of a video that we did of some earlier demos more closely related to the topic at hand today, the automotive industry. So this video will start about, where's my controls?
What are you searching for?
Yeah, I don't have my forward reverse control.
No, I think it's because it's on full screen.
Ah.
There you go.
Okay. There we go. So we have some simulations of various automobiles in this, and you can see here that we've done a little hierarchy based on geographic location of some vehicles. We gather telemetry from vehicles, in this case, some actual telemetry and some simulated. There's the speed of the vehicle. This is actual speed, but it's just repeating it over and over in a loop. And so we can see how fast the driver's driving there and manage that and create alerts on it. Even the things now that you see, what car company is it that you can set thresholds when your children take the car out, right? So VROps could do that. I mean, you can it could send you an email every time your child exceeds a set speed limit. So all that is available today in VROps. So here's a heat map we did. This is simulating the anti-slip differential and whether it's engaged or not in like a four-wheel drive vehicle. And you can see that we've grouped them geographically, and the vehicles in the northeast United States are all slipping because when we did this, it was snowing there, and the vehicles in the rest of the country were not slipping. So that's another way you can present data in VROps.
So Greg, could that be used to be fed into like weather.com to be more precise on weather forecast or actually weather data reporting?
So that would be sort of like integrating with the big data suite from Pivotal. You could do a correlation. You could say, the VROps could say, oh, a bunch of these cars are slipping around Y, and then integrating or making the correlation from some weather services via the big data suite, you could say, oh, it's because it's snowing there. They're not all going bad, it's because it's snowing. Things like that. We did a few demos for insurance companies. This is another view of a topology graph, how you could get to the individual cars. So insurance companies, same kind of thing. They can track the vehicles and their owners, where they've been, set limits, and do some. And then that data can also be used and fed into Pivotal Big Data for deeper analysis. Remember, VROps is really about real-time monitoring, not big data analytics. So just go back to an earlier version in the video. So we have alert set for vehicles for low tire pressure. So that's a pretty simple case. It's the type of alert is an unsafe driving condition. Somebody gets an email, a REST notification goes out, and you can identify the particular vehicle that's having the low tire condition. And I think Emil will take it up from there later.
Thanks, Greg.
So if we find out that actually it's a software bug and it's not suddenly 1,000 vehicles are losing tire pressure, but rather it's a software bug we have to fix. So how would we go about to do this over the air?
So this is the situation right now. We have cars reporting lower tire pressure, hundreds of them, and so basically as a car manufacturer you obviously take a sample car and you check that everything is all right. So as a car manufacturer we were able to basically identify that it was a software configuration issue. It was not a hardware problem, it was not a sensor problem, it was really a software issue on the head unit. So the driver was receiving these notifications like your tire pressure is low. Obviously because the head unit is connected back to VROps, it was communicating this data back, but we figured that it's a software issue. So what we have here right now, and I'll ask you to be a little bit, to have your imagination work. I know it's early in the morning, but I would just ask you to imagine that this is a car here. Okay, this tablet is just the head unit of your car, and what we have is a small demo app where basically, everyone, where basically the head unit is an app. Okay, as you can see here, and we have our navigation system, and in front of our navigation system we have this tire pressure low notification. So obviously in a modern car it would look maybe a little bit better, it will be on the top right corner, but you will still have this notification with some sound usually that goes together, this nice beep, be careful, there is something going wrong. So what we're going to do now is using AirWatch, and I believe most of you here have seen at least the AirWatch console. This is our web console, which is used to manage mobile devices across mobile operating systems. So we have really supporting iOS, Android, and so on, so forth. And basically what I see here is I have my head unit right here, and I'll be able basically to remotely reconfigure it or push a software upgrade to fix this issue. Okay, so how do we do that? It's pretty simple. We have here this application, and I can edit basically the configuration of this application. The great thing about AirWatch, it's multi-tenant, which means that you can really manage your cars per country, per model, per year of production, per specific use case, and you can really assign policies to devices or cars in a very granular way. So what we've done here is we have this software configuration package that we have assigned to all my A series. So let's suppose this is a car from the A series, and above 2012. So all the cars produced after 2012, because we identify that these are the cars that are exhibiting this issue. Okay, so what we'll do is we'll just go ahead here and edit some of the configuration of this car or of this head unit, and we have, what is called here application configuration. So obviously, in the mobile or smartphone or tablet world, we talk about apps, but if you transpose this to a head unit, it will be very, very similar. Okay, so what we will do here is we will just here set this tire warning to false, okay, and basically switch it off remotely. So I just need basically to change this flag and send down the application configuration to this device or to this head unit. Okay, so if I look back at my assignment now, obviously I have here the tire pressure, which is set to false, this warning. So if I go back to my iPad, and if my connectivity plays with me today, basically I will dismiss this one. And as you can see, the warning is gone. Okay, so I have here, my head unit is now working, and I have, my navigation system, my phone numbers, my AC settings. I have some music channels as well, and I can also configure some of the modes of my car. Okay, so this is one way of looking at things. It's basically using remote configuration, we can fix things. But there are many, many other use cases where this can apply to. So imagine you use some car sharing services. Okay, you go inside a car. I personally live in Germany, and we have something called Drive Now, where I have this nice cart, and I can go and open, some of these Drive Now cars and drive them and pay per minute. Okay, and then I just take it, leave it, and that's fine. It's similar. You have something called Zipcar as well in the US. I mean, these services are getting more and more popular. In Paris, you have something called Autolib for electrical cars. So the question is now, as a driver, when I take one of those cars, or even if I rent a car at, our 6th Europe car and so on, rental car companies, I would like to have my settings pushed down to the car. Right? I don't want to sit down, reconfigure everything, the seats, the mirrors, have my radio channels reconfigured. I want to be basically just sitting down, start driving, and have everything as if it was my car. So also for convenience, it's a great way of having some remote control features of your car. So what we can do here is very simply, as you can see currently, this is my car. I just took it from the rental car company or from the the minute rental car service, and there are no radio stations, and there are also no phone numbers. Okay, so what we can do is very simply, in the same way we did before, I can here enable my radio stations, and I can also enable my telephone list. Okay, so if I click on Add and just publish this configuration to my A series, so in this case it's this car here, we'll see it's very, very quick actually. It takes a few seconds basically to arrive on the device, and I will have, when the notification comes down, I will have my phone numbers on the car, and I will also have my my radio stations configured. So this is also another way of looking at things, is basically not only fixing problems, but also enabling users and offering them some nice comfort functions. Okay? So we need to wait a little bit, but once the notification goes to the device, we have our radio channels configured and also our phone numbers configured. Okay? So, and also, finally, we can enable some of the modes. So imagine I'm renting a sports car, and I want to go on the track, and I want to enable some kind of sports mode. We've all heard about Tesla being able to add 40 horsepower to the car via software upgrade. So this is something that we can also do here by very simply assigning here, enabling or disabling some of the modes of the car. Okay, so we have typically a inside mode here that we can enable. We have here some, special body kit that we can enable. And, once we publish that, this gets pushed down to my head unit or obviously to the car, and we can start, leveraging these special modes of the car. So that's all great, but you're going to tell me this is a iPad app. What's common with a car? Where is your car here? So this is where basically I can switch back to my device list and show you a QNX device. So QNX is an operating system that I mentioned before. It's used in many real-time applications that require this real-time operating system. So this typically here is a QNX device enrolled into AirWatch and managed by AirWatch. Okay, so I can do the same things as I did on my mobile app, but on this QNX device, right? And so I have here all kinds of information. I'm obviously gathering metrics from the device as well. I can assign some configuration profiles. I can configure it, etc., etc. One thing which is great and which I believe would be very helpful to many car manufacturers is the ability to remotely upgrade the software in the car. Okay, so either to fix bugs, but also to enable some new features. Okay, software is changing, features are evolving, and we all know on our mobile phones or tablets, we have a software upgrades every few weeks, right? And sometimes when a major release comes out, we have a patch immediately after that. So we're used to this, upgrading process of our mobile devices. And I believe in a car, it could be also useful to be able to upgrade the software to enable some new features in a more dynamic way. Not necessarily driving to the dealership, plugging the car, flashing the ROM, etc., as it's currently done. So we have basically the concept of products into AirWatch. So the product basically is a set of files and actions where you're going to just upload your file. So I have here an example of a new map, basically an update to the maps. Okay, so I drive a car, and so when I want to upgrade my maps because they're outdated, I need to go to the dealership, and they charge me about 300 to 500 euros to have these maps updated on my GPS. Right? I think it's expensive, and I don't have time for that. So why not getting this remotely? So basically what we can do here is just upload the file. So we have here typically a zip file containing some maps. We have some XML configuration file. We could upload whatever we want basically. Okay, here in the product. And basically once we create our product, we have the concept of manifest. So the manifest here, it's basically a set of actions that you can perform on the end device. So as an example here, we can copy the files, create a folder on the operating system, run a specific processes, terminate a process, uninstall an application. It's very pretty flexible. And once you define this set of files and manifest basically, which are the actions, you can create a product. Okay, and inside a product, so as you can see, the product provisioning piece is something that we use commonly for Android devices, for Mac OS X devices, for Windows devices, but also for QNX devices. Okay, so inside the product provisioning here, you can very simply, here specify which groups you want to deploy this package to, so you can very granularly target a model, a car, a build year, a set of drivers, etc. And then here in the manifest, you will just select obviously what you want to do. So here we will just install my files / actions. Okay, so my maps typically. Okay, I can have also multiple software packages installed in a specific row, in a specific sequence. Okay, so I can first install package A, package B, package C, and wait until package A and B are installed before C gets installed. So this is the idea here behind the product provisioning. I can have conditions. That's very important, especially for electrical cars, but also for petrol cars too. You don't necessarily want to have a software upgrade happening while the car is on the road. Right? So you can specify only if the car is in the garage, or if it's charging, or if it's like 3 a.m. in the morning, then push the software upgrade to the car. Okay, so this is what we have here with basically the download conditions. And we can also have the deployment made on demand. Okay, so we can automatically push it, but we can also have it on demand. So imagine the concept of App Store on the car. So you sit down in your car, you have your nice head unit, and you can like install apps. So it would be an on-demand software provisioning, right? This is how it would work using AirWatch to provision some on-demand apps on the device. And then finally, you have also dependencies. So dependencies is similar to what I mentioned before. This software package will only get installed if some other software packages are already on the device. Okay, so this concept of dependencies is also available here. And obviously, if you're familiar with AirWatch, you know that we're pretty good at reporting, at compliance as well, so we can automatically alert as well the driver or the ecosystem if something happens on the car based on the compliance policies you have here. And you can manage obviously the entire fleet of cars using just as a last small detail here. I mentioned multi-tenancy, so typically as a fleet manager or as a car manufacturer, you want to be able to delegate this software provisioning piece to maybe some regional administrators, right? So what you can do using AirWatch is basically, create local administrator at specific, geographies or specific models, specific build years, and these guys will only be able to manage this subset of cars. Okay, so the same concept we do it again with smartphones, tablets, where you have some users, some administrators managing the VIP devices, or only the VIP devices. You can apply it here to specific models, geographies, and so on. So why is this actually important? I mean, it's nice, it's funny. We all love technology here, and we can see the technology benefit of it. But I think it's also relevant for car manufacturers today. So we all heard about the software issues affecting Chrysler in the US, whereby a car was hacked. And the hackers, the two software researchers, were able to remotely control it, drive it, switch off the AC, switch on the radio, etc., and basically stop the car on the highway. Okay, so they had to recall about 1 million cars to fix this software issue. So the software problem was basically a port was open on the head unit. Okay, and the hackers were able to basically hack into the head units via this open port on one of the mobile carriers in the US. Okay, so we can see that just a small detail like that can be used or leveraged to or exploited basically to hack into the car. And there is no bigger tragedy, I would say, for a car manufacturer than recalling cars. It's very expensive, it's time consuming, it damages the image, the brand image. We've all heard what happened to one of the German manufacturers lately around their diesel engines, right? So now they need to fix it. So how do they fix it? They recall the cars. Okay, and this is extremely expensive. It takes time. It wastes obviously the driver's time as well, the customer's time. It's bad for the manufacturer. So one way of doing it, and this is how Fiat also Chrysler did it, is they send flash drives to their customers to plug into the car and automatically perform this software upgrade. That's not bad. I mean, it's better than recalling the car, but you can imagine how much success the success rate will not be obviously 100% on that. Okay, because either you will not do it because you don't have time, or you're not going to manage to find a USB port. It's also not optimal. Okay, so similarly, you have also Audi. They had to recall about 100,000 cars in the US last year because of an airbag software issue. Okay, I don't know what the price is or the cost is for a car manufacturer to recall a car, but 100,000 cars, to recall 100,000 cars, I mean, you can count tens of millions of dollars to perform this. Okay, so imagine you have this remote of the software upgrade capabilities that I just showed. It's obviously a benefit for everyone. So I hope this gives you a bit of an idea of where we're going, what our vision is around remotely managing and upgrading the software in the car. What we want to show you right now in the next few slides and to finish the presentation is basically we want to go crazy, and because VMware is very good at virtualization, why not apply virtualization to the car? And this is where Matthias will take over again.
Right, so software-defined car. If you look at a car, and I said that before, it has up to 100 of those little ECUs in there, and you cannot update them over the air. So every time you want to install a bit of software on those little guys here, you have to bring the car into the dealership. They will plug in a computer into the OBD2 port and then flash those things. right? You can also, by accidentally, flash them broken. Happened to me once. I have a Toyota Prius, and they told me, we have a great new software update for your car, can you bring it in? And after 3 hours, this is no joke, right? After 3 hours, they called me and said, well, we broke your car. And I said, why is that? He said, because we were just about in the middle of flashing, and then the battery went dead. And now your computer is in a state where we cannot recover it. But don't worry, it just takes 2 weeks to get a new one from Japan. Of course, you can have a rental car for that time. And of course, we're paying for it, right? So that's things which happen when you have to flash stuff. So we said, well, when there is software running on those guys, so why don't we take them and virtualize that software? So why don't we take the software out of this guy and virtualize it and let it run on a hypervisor in the car? And then you obviously still need to somehow access those switches and those electric motors, right? But that doesn't go away. So what we have come up with is a concept which we call RSAM, Remote Sensor and Actuator Module, which then still interfaces to the car's electronics and the mechanics. And this thing looks a little bit like a Raspberry Pi, because what you need to have now is a little board which doesn't do anything else but IOs which you can program, and you program it once for a specific purpose, but there is no other logic on it than only to tell it which IO pin does what, and that never changes, right? Once the car is built, the whole thing is connected via Ethernet. And obviously, you can add your switches and electric stuff. So we thought that's really crazy, and we still were bold enough to walk by a automotive supplier, and we showed them that picture, and they said, "Well, it looks pretty much like what we are planning to do. Let's talk, right?" So they brought us to a room which is like no windows, all secrecy. And we talked about those things, and it turned out that our concept, which we just came up like overnight, matches quite what the car industry actually wants to go to. So there will be Ethernet in your car. So all those buses will go away, right? It's not the Ethernet you and I know, so they talk about high-speed Ethernet and they think 100 Mbits is high, right? But it's still Ethernet. So we said, well, once we have that, we can actually have fault tolerance, right? Because we are data center guys, and we want to make everything like fault tolerant. And if you're sitting in an autonomous driving vehicle, hurtling down the German Autobahn on 200 kilometers an hour, sitting in the back playing cards with your friends, the last thing you want to happen is a software failure crashing your car, right? Or a piece of hardware failing, stopping the car from doing what it's doing. So we say, well, we could do the same thing we do in the data center, basically. So we have two head units. One is like in a hibernation mode, and the other one is in a running mode. And now we can fault tolerant between those two. And if one goes, the other one takes over, and you won't even notice, right? The car would still go down the road. Of course, it would warn you and tell you, well, there's something wrong, but it's not like suddenly crashing into the next pillar. It's at least in a state where you can drive this car to the side of the road. So what about security? I mean, Ethernet in the car, and we just heard from Emil that someone hacked the car, right? And they got into an open port, and from there they could actually access the whole car. Now, what they in fact did, they used a digital radio broadcast to seize control. So what does that mean? So here's the guy, right? A hacker. And he hacks the radio. I mean, it's the bloody radio in your car, right? And so suddenly, once he's in the radio, he can access the brakes and everything. That is because, and I come back to those 100 million lines of code, this is a huge monolithic block of software. And once you're in any piece of that software, you can get across to all the other functions and do whatever you want to do, right? So this is scary. But this is what happened at Chrysler. So what we came up with, we said, wow, so first of all, once you're running on a hypervisor and you're separating those different functions, they have already quite a good isolation level, right? So that's why we're doing hypervisors, right? Because we want to fence off applications from each other. We want to make sure that if for whatever reason someone is hacking the, let's say, the air conditioning, it doesn't mean they suddenly can control the lock of the car. Well, you still have Ethernet in between, so wouldn't it be cool if we could use something like NSX to actually microsegment that stuff, right? Because now we can go ahead and make sure that that red thing here, that body control module, which controls things like the locking and the burglar alarm, is only talking to those control systems which are related to air conditioning, right? And even someone breaks into this thing, they won't be able to control anything else, even through the network. So the other thing you can do, once you have that all virtualized, you can actually run beta versions of the software in 1 million cars without the owners of the cars even knowing, right? Because let's imagine you have the body control module in a version 1.0 and you want to actually come up with a version 2.0. You have to test that really thoroughly, and testing it in a test environment, and we learned that from the Volkswagen thing, right, might create different results from when it's actually used in live conditions. So what you could do, you could shoot that software update using AirWatch, putting it into that head unit. It runs in parallel to the existing software, and it gets all the sensor information, but we prohibit it from accessing the actuators, right? So this software would just say, I would now actually apply the brakes, but it doesn't apply the brakes. We're getting all those logs, and we can use VROps to actually get that data off the car and then analyze it at home in our nice warm office at the car manufacturer, right? And once you are really sure that this software is is doing what it's supposed to do, you can actually then provision it to the car and disable version 1.0, enable version 2.0. Everything's good. The owner didn't even know that you did that, right? So that's the idea. So you might say, is there any evidence that you guys are working in the car industry? And yes, there are. So we're working with a global engineering company exactly on this idea of an IoT cloud, an Internet of Things cloud, which for them encompasses everything, also cars. So they have already found that they need a cloud to manage all those devices and to get all the data out of those devices. And we're working with an automotive supplier, which is actually really reaping megabytes, petabytes of data out of the cars, out of autonomous driving vehicles, and has to analyze it. Then a fleet management company which is using predictive maintenance. I said the truck industry is far ahead on this. So predictive repairs is a really big thing, because if you can predict that something is going to break in a few weeks' time, it's usually easier to fix it than once it's broken. We're working with General Electric aviation engines. They are taking data out of the turbines from aeroplanes and do preventive maintenance with it. And that's a huge cost benefit, because if you can, rather than taking this engine apart every time it's in the shop, just take it apart when really something is broken in it, it's a huge cost benefit. Last but not least, insurance companies, I said it before, they are highly interested in getting that data to have new innovative car insurance policy plans. So what you've seen is that you can use vRealize operations not only to monitor your servers, but you can do other stuff. And I encourage everyone who has vRealize operations in the shop and think about what else you could monitor and maybe correlate that data with your servers. There's Columbia Sportswear, for example, they're feeding weather data into the system because they know when it starts to get cold, people will buy different clothes, right? When there is a hot weather coming, people will buy more bikinis, and they can configure their systems accordingly doing this. Right, cars are smartphones on wheels, and that's what the car manufacturers themselves say. So we can use AirWatch to actually manage them. We can use VMware technology to software define the cars, the same we software define the data center, which means for the car manufacturers, they can reduce the number of recalls. They can create completely new services for their customers, and the electrical design of the cars will be much, much simpler than it is today. And for you as a driver, obviously, you don't have to go to the dealership so often. Many things can be fixed over the air. Software will make it better over time, right? So there might be you buy a car which has a normal stereo with 4 speakers, and after 3 years you decide you want to have 12 speakers. Usually the speakers are in the car already, they're just not enabled, right? But you could then buy that feature on the website of the car manufacturer, and a few minutes later it will actually be enabled in your car. And obviously you can customize your car because it's all software defined. So with that we are through, and I think we have time for a few questions. So let's go ahead and are there any questions? No questions. All right. Very cool. But one question we got last time when we did this in the US. Someone got up and said, I will not buy a software-defined car unless I can root it.
Yep.
I found it very interesting because it might be okay to root your mobile phone, right? But I'm not sure you really want to root your car. But that guy said, no, I'm not going to buy the car unless I can root it. Okay, fine. Your decision.
Yeah, the scenario was the following, because obviously because it's software defined, you will always have people trying obviously, to push some additional packages on it or, hack around. And using AirWatch, because we do jailbreak and root detection on smartphones and tablets, we can also make sure that the software that runs on the head unit has all its integrity basically. So we could do root or jailbreak detection on the car and typically stop the car or like notify the police maybe, who knows, if the car is rooted or jailbroken. And this gentleman stood up and say, I would never buy this because I like playing with my phones, I like rooting them, and I will never buy a car that is completely controlled and I cannot hack around, basically. Yeah. This is the background.
Any last thoughts from you, Greg?
Oh, I just want to say we have another talk at 1:30.
Oh, yeah.
We're going to repeat the general VMware and IoT talk, and I'll give a live demo with Intel IoT Gateway and VROPS in that talk. It's in room 45, I think.
And you also have a demo in the shop floor, right?
Right, so in the Intel booth, there's a smart building demo, and in the office of the CTO booth, there's the gateway to VROPS demo.
All right.
And the smart building also uses VROPS.
All right. Okay, gentlemen, thank you very much.
Thank you.
Don't forget to fill out the surveys, please, and have a great show.